Hello dear students, I am Professor Priya Kulkarni from Parvati Bai Genba Music College of Engineering, Wagholi, Pune, and here we'll see one numerical or we'll see the background for the flexibility matrix method. Okay, so this is very important topic in our SA2 subject. Okay, so in the previous lectures we have seen the background required for the flexibility matrix and how to create the flexibility matrix we have seen there. Also we'll repeat here and we'll start with the one numerical and we'll continue in the next lecture with the flexibility matrix for a portal frame. Okay, so due to time being we'll see the flexibility matrix method, and I will give you the notes uh, or I will solve some I have solved some numericals and I will give the notes directly and just study them well, and if you have any doubts then directly contact me. Okay, so what is the syllabus that we have to cover in this unit is the fundamental concepts of flexibility matrix method of analysis. Okay, so that part we have seen in the previous lecture, and formulation of flexibility matrix, application to pin jointed plain trusses not involving more than 3 unknowns. Okay, then application of flexibility method to beams and rigid jointed rectangular portal frames involving not more than 3 unknowns. Okay, so this is the syllabus that we have to cover in this unit. So most of the structures in the world are statically indeterminate structure. Okay, why we have to provide indeterminate structure? Because we have to select the adequate size of the section or adequate sections of the section structure. If we go only for determinate structure, then we'll come with a very large or very big size of sections, or the dead load of the section is very much. So we'll for that condition we'll go for indeterminate structures. Okay, so determinate structures can be analyzed by using the equations of static Carnot that we know, but in indeterminate structures where number of reactions is greater than number of equilibrium equations, either reactions or internal forces cannot be determined by the statics equation. Hence, in addition to static equilibrium equations, compatibility equations are necessary. So, just keep in mind that the determinate structure can be analyzed with the equations of statics alone, that is summation of horizontal forces is equals to 0, summation of vertical forces is equals to 0, and summation of movement is equals to 0. That from these three equations we can analyze the determinate structure, but in indeterminate structure we cannot analyze our structure with these three equations only. We need additional equations, and that equations are known as compatibility equations. Okay, so what are the compatibility equations, and where do we have to use that compatibility equations is determined from the number of unknown forces in the particular structure. Okay, number of unknowns in the particular structure. Obviously uh, it should or it cannot be identified with the basic equilibrium equations of the static. Okay, so for any structure as a whole, it needs to satisfy equilibrium equations, that is structure is must be in equilibrium, otherwise it will fail, and compatibility equations, that is continuity of structure without any break. That means we have assumptions, or we have seen many assumptions, or in the most part or in our SA2 or SA1 subject, that is the structure is homogeneous. What do you mean by homogeneous? Homogeneous means it is the integral, or it should maintain the integrity of the structure. There should not be any break, or there should not be any material change. Okay, or rather if we have to provide any material change, then we have to maintain the homogeneity at the joints. Okay, or we have to make that particular joints much more stronger. That means the homogeneity. Okay, so force and displacement relation, how displacements relate to the force. And basically there are two methods of analyzing indeterminate structure. So, how to solve or how to form a flexibility matrix? For that, we have to consider some steps related to the redundancy. Okay, a systematic development of consistent deformation method is also known as flexibility matrix method or force matrix method. Just remember very carefully that flexibility matrix method is a force method. Okay, so we know there are force methods and displacement methods. Okay, we have discussed about it, but just remember flexibility matrix method is a force method. In this method, the basic unknowns to be determined are redundant forces. Hence, the degree of static indeterminacy of a structure is calculated first, and then coordinate number is assigned to each redundant force direction. Okay, so we are here to find out the unknown, and that unknowns are the redundant forces. Okay, and how to find out that unknown or redundant forces? So we are going to assign a coordinate number and then we'll form a matrix. So just for example, if FF is a fair redundant force, uh, is a fair redundant force in coordinate direction 1 and then 2 respectively, the restraints to enter redundants are removed, resulting the structure called basic determinate structure or release structure. So, as we have done in the previous units, that we are going to release that structure and we are consider it as a determinate structure, and then we'll solve. But how to consider, or what is the criteria to consider, or what is the criteria to release that structure? So we are getting help of compatibility equations, and then only we can assume that given structure as determinate structure with the help of compatibility equations, and then we'll solve, and then we'll form this type of matrix. Okay, from the principle of superposition, the net displacement at any point in statically determinate structure is the sum of displacements in a basic determinate structure due to applied loads and redundant forces. So by this principle of superposition, we are forming a flexibility matrix. So basically we are going to form a 3 by 3. Okay, 3 by 3, that is the limit for our that is the limit they have in our syllabus. So we'll form that matrix and we'll solve for the redundant forces, and we'll get the redundant forces, and it will over our complete numerical. Okay, this method is very easy, and just we have to remember some standard displacements of particular beams. That is, if a UDL is there and if suppose the point load is given, such type of standard displacements. Displacement means what? It is rotation and deflection also. Okay, not only the deflection. Deflection is measured in mm, that is uh, change in the it is a downward displacement or upward displacement, like that. Okay, and rotation is theta, that is measured in radians. Okay, that is rotation. So
these standard rotation and displacement deflection values you have to aware of it, and then you can easily form a flexibility matrix, and will get the equations depending upon unknowns, that is 2 to 3 unknowns. Okay, so we'll solve that equation with the help of calculator and we'll get the unknown, that is redundant forces. Okay, and it will complete our numerical. So what are this part we'll see in the numerical only. So what are the application of this flexibility matrix method? For the analysis of pin jointed plain truss, for the analysis of continuous beams, okay, and also for the analysis of rigid jointed rectangular porter frames. Okay, and there are steps, there are total 9 steps to solve the flexibility method. So first 2 3 steps are same or common in all, and last 2 3 steps are common in all the units of our SA2 subject. So first step is obviously getting the degree of styling determinacy, D. Then choose the redundant. Choose redundant means what? Whatever unknowns are there, that we have to select in terms of forces. Okay, the deflections and rotations we know, and we will use those unknowns, or sorry, we will use those displacements for the standard values. Okay, so that part we know here. So we'll get or choose the redundant means what? We are going to select the redundant forces, unknown redundant forces. Okay, then assign the coordinates to the redundant force direction. Assign means what? Suppose first we'll consider for UDL, then we'll consider for point load, likewise, and the location, that is at point A, at point B, at point C, likewise. So we are going to assign locations, and we are going to assign the load numbers. Okay, it will help in forming the matrix. Then remove the restraints to redundant forces and get basic determinate structure. So it is very important step. So we are going to remove the restraints and we will consider it as a determinate structure. Okay, then determine deflections in coordinates due to given loading in the basic determinate structure. Okay, so this part we know, and we have to remember the standard displacement values for the beams. Okay, deflection and for rotation. Okay, then determine the flexibility matrix. So from this fifth step we'll easily form this flexibility matrix. Then apply compatibility conditions. Okay, so this is very important step. We are going to apply the compatibility condition. Then we'll get 2 or 3 equations, and by solving in the calculator we'll get the redundant forces, unknown forces. Then final step is drawing the shear force and bending moment diagram. For that we require the shear forces and bending moments at the particular ends or supports, and we'll finally draw the shear force and bending moment diagram. So this will complete our flexibility matrix method numerical. Okay, the steps are easy, and this unit is also very much easy, and it is also less time consuming unit. The whatever what expected from you is just remember the displacements of the standard cases. Okay, I will give that part in PDF form after this lecture overs. Okay, so in the next lecture we'll start with the numerical and we'll complete this unit. Okay, so thank you. If you have any doubts, then contact me and comment your name and roll number in the comment box for the attendance purpose. Thank you.